Okay, so we're going to pick back up again here in chapter one, and we're going to work on defining classes. And just remember that we did this before in the old book. Last chapter we worked on here, and so this is going to be a lot of review stuff, but there's also a lot of new stuff in here, and especially when we get into chapter um, or into the fraction class, and it's got some other stuff in there that we haven't done before that I think will be interesting for you. So. We started or stated earlier that Python is an object-oriented programming language. So far, we have used a number of built-in classes to show examples of data and control structures. One of the most powerful, let me get this started here for you, sorry. One of the most powerful features in an object-oriented programming language is the ability to allow a programmer, the problem solver, to create new classes that model data needed to solve the problem. Remember that we use abstract data types to provide the logical description of what a data object looks like, its state, and what it can do, its methods. By building a class that implements an abstract data type, a programmer can take advantage of the abstraction process and at the same time provide the details necessary to actually use the abstraction in a program. Whenever we want to implement an abstract data type, we will do so with a new class. So this is the fraction class that I talked about. A very common example to show the details of implementing a user-defined class is to construct a class to implement the abstract data type fraction. We have already seen that Python provides a number of numeric classes for our use. There are times, however, that it would be most appropriate to be able to create data objects that look like fractions. A fraction such as 3/5 consists of two parts. The top value, known as the numerator, can be any integer. The bottom value, called the denominator, can be any integer greater than 0. Although it is possible to create a floating point approximation for any fraction, it, in this case, we would like to represent fractions as an exact value. The other thing is that we will only be working with positive fractions, so our numerator and denominator will both always be positive for the examples we'll be using in this chapter for this. The operations for the fraction type allow fraction data object to behave like any other numeric value. We need to be able to add, subtract, multiply, and divide fractions. We also want to be able to show fractions using the standard slash form, 3/5. In addition, all fraction methods should return results in their lowest terms so that no matter what computation is performed, we always end up with the most common form. In Python, we define a new class by providing a name and a set of method definitions that are syntactically similar to function definitions. For example, class fraction, and then the methods that we need will go underneath that. This provides the framework for us to define the methods. The first method that all classes should provide is the constructor. The constructor defines the way in which data objects are created. Another name for constructor is initializer. In Python, it's the init. To create a fraction object, we will need to provide two pieces of data, the numerator and the denominator. In Python, the constructor method is always called init with two underscores before and after the init, and is shown in listing 1, 2 on page 31. Okay, we're going to go ahead and start by creating this. And I need to do a little cleanup here because I already created this stuff to test it out and make sure it worked. So I'm going to get rid of this stuff here. And so in Python, I'm going to go ahead and open up a new file. And then what we're going to do is we're going to start with creating the class. So class fraction, and then the init method, def underline underline init underline underline, and then we have self as our first parameter. We're going to use top as our second parameter and bottom as our third parameter. Okay, those are being passed in, so we have our numerator and denominator. We need to set up our attributes. So we have two attributes. We're going to call the first one num for numerator. It's going to be equal to top. And then we're going to have our second one self.den for denominator. It's going to be our bottom. Okay, so that gets all that set up. I'm going to go ahead and get this saved. And like I said, I already did this. So when I get over here to where I'm saving it, I already have it in there, so I'm just going to save over the top of it. Fraction, save, and yes. Okay, so we got that created. Let's go back to our PowerPoint. Notice that the formal parameter list contains 3 items, self, top, bottom. Self is a special parameter that will always be used as a reference back to the object itself. It must always be the first formal parameter. However, it will never be given an actual parameter value upon invocation. As described earlier, fractions require 2 pieces of state data, the numerator and the denominator. The notation self.num is in the constructor defines the fraction object to have an internal data object called num as part of its state. That's for the numerator. Likewise, self.den creates the denominator. The values of the 2 formal parameters are initially assigned to the state, allowing the new fraction object to know its starting value. To create an instance of the fraction class, we must invoke the constructor. This happens by using the name of the class and pass actual values for the state. Note that we never directly invoke init. You don't ever call init by saying something like x.init. You don't do that. That's init is called automatically when you create the instance. So for example, my fraction equals fraction 3 comma 5 creates an object called my fraction representing the fraction 3/5. Figure 1.5 on page 31 shows this object as it is now implemented. The next thing we need to do is implement the behavior that the abstract data type requires. To begin, consider what happens when we try to print a fraction object. So you can kind of look at that, and I'll come back to it here in a second. Let's go ahead and try that ourselves. So what I'm going to do is I'm going to create open up another file, or create a blank file here, new. Okay. So what I'm going to do is I'm going to do from import. I'm sorry, whoops, wrong on here. From fraction, lowercase because that's what I saved it as, import fraction uppercase because that's the name of our class. And in our main, I'm going to call this frac1 for fraction 1. It's going to be equal to fraction dot, fraction, and then in parentheses, I'm going to do the 3 comma 5. Okay, so that's what I'm going to do that. Now all I want to do is print out this fraction, fraction 1. So let's see what happens. I'm going to go ahead and save this. And I'm going to call it fraction test. I've already got that out there, so I'm just going to save over the top of it. Okay, and I'm going to go ahead and run this. And that's the line that I get. Fraction.fraction, object at, and then this long thing here. What it's doing here, let's go back over to the PowerPoint now. I'll explain this on here. Okay, so theirs looks a little bit different than what ours looks like on there. Okay, which is fine. It's going to be different depending on how you set it up and everything. But the fraction object, myf is what they use, does not know how to respond to the request to print. The print function requires that the object convert itself into a string so that the string can be written to the output. The only choice myf has is to show the actual reference that is stored in the variable, which is the address. There are 2 ways we could solve this problem. One is to define a method called show that will allow the fraction object to print itself as a string. We can implement this method as shown in listing 1.3 on page 32. Now we're not going to do this, okay, because it doesn't really help us out for what we really want to do. So I'm just getting to where it is on the book here because I didn't put it in the PowerPoint. So on page 32. Okay. So what it does here is we create a separate method called show. And then inside the method, we use a print statement to print the numerator, the slash, and the denominator. And then in the main program, in this case, we're using the shell, but in the main program, if we wanted to display this, we would have to use myf.show. The print still doesn't work. It still does the same thing because that's not what we did. But we really want the print to work here. So if we create a fraction object as before, we can ask it to show itself. In other words, print itself in the proper format. Unfortunately, this does not work in general. In order to make printing work properly, we need to tell the fraction class how to convert itself into a string. This is what the print function needs in order to do its job. In Python, all classes have a set of standard methods that are provided by, but may not work properly. One of these, str, is the method to convert an object into a string. The default implementation for this method is to return the instance address string as we have already seen. What we need is to provide a better implementation for this method. We will say that this implementation overrides the previous one or that it redefines the method's behavior. To do this, we simply define a method with the name str and give it a new implementation as shown in listing 1.4 on pages 32 to 33. Okay, so try to get my mouse over where I need it. There we go. Okay. Okay, so it shows you there how that works, and with the print statement, and it also shows you that you can use str as a method, which we are not going to do. We're always going to use it from print. So this definition does not need any other information except the special parameter self. In turn, the method will build a string representation by converting each piece of internal state data to a string and then placing a slash character in between the strings using string concatenation. The resulting string will be returned anytime a fraction object is asked to convert itself to a string. Notice the various ways that this function is used. And again, we're only going to use it the one way. So let's go back into our fraction class here. And we're going to create our string str method. It's underline, underline, str, underline, underline. What we want to do in here is we want to return, and I want to make sure I get this right, so let me, there we go, okay. So I want to return str of self.num, okay, and we need to use the str because num is an integer or a numeric value, and with the plus concatenation of strings, it has to be a string. Okay, so we're going to add in a forward slash plus str. Whoops, no quote there. Of self.den. Okay, and that's all there is to this one. Okay, so let's test this out. I got to save this. Do Control S to save that. I'm going to go over to our test program. I've already got that in there to work there, so I'm just going to run this. And there's the 3/5 that we did. So all works. Let me know if you have any questions about that, okay? Okay, so let's continue on here then. So we can override many other methods for the fraction class. Some of the most important of these are the basic arithmetic operations. We would like to be able to create two fraction objects and then add them together using the standard plus notation. At this point, if we try to add two fractions, we get the following. Okay, so we're going to do this and go back over to our test program here. Okay. I got frac1 equal. I'm going to change this to 1/2. I'm going to create another one. Frac2 is going to be equal to fraction 1/4. And then I'm going to do right here frac3, that's going to be equal to frac1 plus frac2. Okay, looks normal. Everything should work right because it's just values that we're wanting to add together here. So I'm going to save this and run it. And what I get is this crash here, type error, unsupported operand types for plus, fraction, and fraction. And what it's saying is the plus in Python works only in two ways. You can add numeric values, such as integers or floats, or you can concatenate strings. It doesn't know what to do with fraction because fraction is an object, so it can't do that. Let's go back over here and see what's going on. Okay, so this is showing the same thing that I did there with the error message and everything there. So if you look closely at the error, you will see that the problem is that the plus operator does not understand the fraction operands. We can fix this by providing the fraction class with a method that overrides the addition method. In Python, this is called add with the underline in front and back, and it requires two parameters. The first set is always needed, and the second represents the other operand in the expression. Okay, so we have the example is f1 dot underline add underline f2. This would ask the fraction object f1 to add the fraction object f2 to itself. This can be written in the standard notation f1 plus f2. Okay. I'm going to stop there because we're going to run out of time. I don't want to get this too long on here. So I'll stop there. We'll come back to two fractions must have the same denominator to be added, and we'll work from there to figure out how we're going to do this. So if you have any questions on this, let me know, and I will get back to you as soon as I can. Bye.